Good afternoon, everybody, and welcome to the next iteration of the ACBI webinar series. Today we're going to be giving a brief overview of two very exciting projects recently created as part of the Advanced Commercial Buildings Initiative collection here at Southbase. The first is the Campus Benchmarking Guide, and the second is its sister document on submetering energy usage for campus buildings. To thank everyone for joining us today, we will be sending a follow-up email containing both the recorded webinar as well as a link to the tools themselves. So without further ado, let's go ahead and dive right in.
Good afternoon. I'm Juliette Apicella, Southbase Program Manager for the Atlanta Better Buildings Challenge. Southbase is one of the program's founding partners and serves as the primary technical assistance provider. We provide one-on-one technical assistance to building participants and provide program evaluation, data management, and program development services to the program.
Hey everyone, I'm Gray Vickery. I'm a fellow here on the commercial team. I've been at Southbase for about 9 months. I'm relatively new to the energy industry, but I'm very excited to be here.
Southbase is a membership-based nonprofit located in Atlanta, Georgia. We're focused on promoting sustainable homes, workplaces, and communities. Our work is focused in 4 areas: education, advocacy, research, and technical assistance. This is a picture of our main campus. The Resource Center is on the left, and the Eco Office, completed in 2009, is on the right. The Eco Office is a LEED Platinum, Energy Star, and Earthcraft Light Commercial certified building. The building serves as an example of high-performing small commercial buildings and acts as a research and demonstration facility for the organization and the community.
So what is ACBI? ACBI is a 3-year-long research project funded by a $4 million grant from the U.S. Department of Energy. We're currently in the last year of the grant, meaning that the bulk of the toolkits have been developed and we're now deploying them into the market. The main focus of ACBI was to create research-driven solutions to achieve broad industry-wide adoption of energy efficiency for small commercial buildings. Now, by small commercial buildings, we're referring to buildings under 50,000 square feet. The project focuses on both new and existing buildings and aims to achieve a 20% reduction for existing and a 50% reduction for new, as outlined by the Architecture 2030 Challenge. So really the primary objective was to develop simple, affordable, and accessible protocols for design, energy assessment, and data collection, and also to engage stakeholders in testing innovative financing options. The structure of the program consists of a research phase, a demonstration phase, and a deployment phase. During the research phase, we did a lot of circuit-level monitoring, utility monitoring, a lot of diagnostic testing, blower-door testing, and computational modeling. We're now through the research and demonstration phase and entered the deployment phase. So why small commercial? What makes small commercial buildings so special? Well, the Department of Energy funded this project to focus primarily on small commercial buildings for a reason, a very good reason. When we look at the data, we see that the the commercial building stock is dominated by small commercial buildings. As you see in this chart, 94% of the buildings in the commercial building stock are in fact small commercial. Now, the statistics for floor space are somewhat different, but we still see that roughly half of the floor space in the United States is taken up by small commercial buildings. So how is this relevant to benchmarking a college campus? Well, when we look at college campuses and the distribution of buildings across the college portfolio, we see a similar pattern, with a larger number of buildings being under 50,000 square feet. As is demonstrated in this graph, when we look at fuel consumption, nearly half of the fuel consumed in the United States by commercial buildings is consumed by small commercial buildings. Historically, large buildings have always almost been the primary targets for energy and water savings efforts, while all of these small buildings have essentially fallen through the cracks. Well, the way we see it, this is a misstep in energy management. All these savings opportunities are sitting there just waiting to be tapped into. So we set out to create tools to make the market for small commercial energy efficiency accessible to the industry. And that's really what's at the heart of this program. So ACBI, before ACBI was initiated and what really sparked the project, we noticed a general pattern across the energy industry. First, we saw that there was an insufficient building assessment tools and protocols for assessing buildings. We saw inadequate data collection and feedback systems. We saw a general lack of technical knowledge and specialized skills, a poor perception of third-party energy efficiency experts, and a limited access to financing for energy efficiency projects. Well, we set out to change that. ACBI builds on the tremendous success of local and Southeast regional energy efficiency programs for commercial buildings. including but not limited to Grants to Green, which is an energy efficiency program created to help local nonprofits achieve energy efficiency, Earthcraft Light Commercial, which is actually one of our in-house certification programs. ECLC is a regional and affordable green building certification program that recognizes environmentally responsible design and construction practices for small-scale commercial buildings in the Southeast. The City of Atlanta Loan Fund is another project that was leveraged in the Advanced Commercial Buildings Initiative, and also the Atlanta Better Buildings Challenge. So Juliet, why don't you tell us a little bit more about the ABBC?
The Atlanta Better Buildings Challenge was launched in 2011. It's a public-private partnership led by the City of Atlanta's Office of Sustainability. The goal of the challenge is to reduce energy and water consumption in Atlanta's commercial buildings by 20% by 2020. In 2015, the program reduced energy use intensity by 17% and reduced water consumption by 20%, saving over 166 million gallons of water and achieving its 20% water efficiency goal. A key factor in the success of the program can be attributed to Mayor Kasim Reed's leadership. The ABBC is a top priority in fulfilling his vision of making Atlanta a top 10 sustainable city. The ABBC is making measurable impacts on Atlanta's energy and water use while supporting the local economy and building the clean energy industry.
So what can this toolkit do to help your campus? Well, this toolkit is designed to help your campus develop a prescriptive strategy to implement energy and water efficiency measures on campus buildings. In turn, this will reduce energy consumption, reduce greenhouse gas emissions, reduce utility costs, and also help earn meaningful recognition in your local community, as well as within the higher education sustainability network. So this is our process that we've developed, our 7-step prescriptive structure. The first step is planning, which is basically mapping your organization's reduction collection abilities. The second is benchmarking. Then we go into identification of underperforming buildings. From there, we do the energy assessments. After that is where the rubber really hits the road, where the measures are actually implemented. And from there, you do tracking, reporting, and further benchmarking. And then the final step is recognition.
Phase 1, planning has 3 key steps: organizational mapping, establishing a project team, and setting performance goals. The first step in planning is organizational mapping. This is where you plan your campus's energy and water management approach to align with your institution's energy and water utility data tracking capabilities, cost reduction targets, and sustainability initiatives. Communication and campus-wide collaboration are critically important for a successful energy and water management program. The first step to establish is lines of communication, division of labor, and accountability frameworks. Mapping your organization's management of utility cost and consumption data and sustainability targets requires the following questions be asked. Who receives and pays for the bills? What budget covers the bills? Are individual departments accountable for energy and water use expenses? Are energy and water tracking or utility cost tracking tools already in use? Are buildings individually or centrally metered? Is energy and water or other sustainability initiatives communicated to students and staff? Is there an informational feedback system or communication loop already in place? In establishing a project team, teamwork is an essential component to successful building efficiency programs. To streamline the process of tracking utility data, it's recommended that a project team be established at the beginning of the effort. Project team members were identified during the organizational mapping effort. Assigning tasks to specific staff members will increase staff exposure to utility information and distribute the workload. Project team member responsibilities in a successful energy and water management program are utility bill management, and that's those individuals that receive and pay for utility bills and may also allocate fiscal utility costs back to departments. Utility data management analysis, and those individuals are responsible for managing utility data, and interns can help log data and generate energy consumption reports. The facilities management, operations, and engineering teams are those individuals who oversee building operations to ensure that systems are operating efficiently and to routinely perform preventative maintenance. And the communications team. Communications communicates progress towards conservation goals to students and staff in a format to drive behavioral change, typically through a digital dashboard or web interface. The program team should include individuals representing those departments on campus. Those include administration, facilities, maintenance and operations, staff and faculty, and the student body, and your local community. To maintain knowledge long-term as attrition occurs, plan to document processes and lessons learned to transfer the program's knowledge to new team members as they come on. Setting performance goals. So establishing energy and water reduction goals on the timeline to accomplish these goals. The goals should be achievable and aligned with the organization's strategic plan and policies and commitments to other efficiency programs. Setting measurable goals helps to verify the return on investment of energy and water improvements, foster ownership of resource management responsibilities, demonstrate the organization's commitment to environmental stewardship, and spread awareness across campus. And here we've got several examples of programs that colleges and universities may be involved in, those including the Better Buildings Challenge, the Atlanta Better Buildings Challenge, the STARS program of ACBI, and the Carbon Commitment and Climate Commitment program. Phase 2 is benchmark campus buildings. Benchmarking is the process of evaluating the energy and water performance of a building relative to key indicators, including the historic performance of the building itself and the performance of similar buildings. Performance is measured in 12-month periods. The steps to benchmark a campus includes establishing a baseline year and defining property use details for each building. So in setting a baseline, the baseline will help you compare consumption on an annual basis and allow progress to be tracked over time. So set a baseline year that represents a typical year of utility consumption history prior to the completion of efficiency projects. The baseline year must have complete data and be without data abnormalities. That would be gaps or just errors that could be attributed to mistakes in billing and those types of things. Campus buildings may have different baselines because they were recently constructed or did not have clean or complete data for that preferred year. Buildings benchmarking utility consumption over a 3-year period saved an average of 2.4% per year, totaling 7% savings. This was a study that was done by the EPA. Portfolio Manager is a tool that was developed by the US EPA, is a free online utility benchmarking tool. Portfolio Manager is the most widely used program to track building performance and is used by more than 40% of the commercial buildings in the US. Portfolio Manager provides a relevant source of comparative energy performance metrics by normalizing energy data for weather and property use details, which include things like numbers of workers, computers, and operating hours. You'll begin benchmarking by gathering and entering building details and utility data into Portfolio Manager or another utility management software program that you may be using. Benchmarking individual buildings requires that each participating building be equipped with a utility meter or submeter to track its energy use. Multiple buildings served by a single meter can be benchmarked as a single property. A successful benchmarking program doesn't require the involvement of every building on campus. When entering buildings into Portfolio Manager, choose the property type which most closely matches its use. So we often see participants automatically selecting the college, university building type for each building on their campus, and you can do that. However, there are many choices that would be better choices that would more closely resemble the way that the building's being used. Energy Star has identified 80 property types with relevant median energy use metrics for comparisons to commercial buildings, including those commonly found on campus and universities. And what you see here in this slide is an example of 25 common campus property types. There's a full list available of those 80 property types by Energy Star. You can reference those in the national median table. Phase 3 is evaluating results to identify underperforming buildings with performance comparison metrics. In this phase, you'll compare current to past performance or compare current performance to the performance of other buildings or use other performance comparison metrics such as a weighted percentage and energy and water cost indexes. Energy use intensity. Source or site energy use intensity. Energy use intensity is calculated by dividing the total energy, the electric or gas energy sources consumed by the building in a year's time, measured in kBTUs, and divided by the total gross square floor area of the building. Water use intensity is calculated in the same manner. Total gallons consumed in 1 year divided by total gross square floor area. Since these metrics factor floor area for the calculations, it's important that your numbers be accurate. Source energy use, or source EUI, is the total amount of raw fuel that is required to operate your property, in addition to what the property consumes on site. The source includes losses that take place during generation, transmission, and distribution of energy, thereby enabling a complete assessment of energy consumption resulting from building operations. Site energy use is the annual amount of all of the energy your property consumes on site. This is the number reported on your utility bills. The EPA has determined that source energy use is the most equitable unit of measure to use and is the unit of measure used by the Department of Energy for the Better Buildings Challenge. Comparing current to past performance. Once your building information is entered into Portfolio Manager, you can begin analyzing its performance using methods of comparison. The purpose of this step is to identify poor performing buildings that may be good candidates to receive building assessments. Here's information in Portfolio Manager using source EUI for the baseline year for this property. In this case, it's our building South Face, and the current year. It shows the energy use for the South Face campus has been reduced by 22.6%. Comparing current to other buildings. The national median is a recommended metric to benchmark buildings. The metric represents the middle of the national peer building group's energy use. Half of the buildings in this group use more and half use less, and serves as a reference to compare relative energy performance. National medians are reported in Energy Star Portfolio Manager. Your building's energy consumption is impacted by weather. Portfolio Manager weather normalizes or adjusts your energy consumption metrics to measure the energy your building would have used under average weather conditions, taking into account increased energy use caused by unusually hot or cold periods. In managing campus building performance and targeting savings opportunities, we suggest viewing building data from a campus or portfolio perspective. The table here represents a suggested method for comparing buildings on a typical college campus using source EUI, the national median source EUI, weighted energy and water consumption, cost per square foot metrics to determine which buildings may yield the highest energy savings as a result of energy and water improvements. The first step is to compare each building's EUI against the national average EUI, and then calculate the percentage of total campus energy and water used by each building. Buildings consuming a large percentage of the campus's total energy and water have which have high EUIs or WUIs, are good candidates for energy and water efficiency improvements. Finally, look at the utility cost per square foot, or energy cost intensity and water cost intensity for each building to determine which buildings have the highest energy and water costs. The 4 small commercial buildings highlighted total 179,000 square feet and together account for 20% of the campus total energy use.
All right, folks, let's move on to phase 4, about halfway through. So now that you've identified a list of underperforming buildings in step 3, the next step is to actually go out and conduct energy audits on those buildings to produce a detailed summary of actual realistic steps that can be taken right now to reduce energy usage. So these steps will range from simple operational adjustments like thermostat setbacks, runtime adjustments, something we call in the industry retuning, all the way to minor equipment replacements like installing point-of-use water heaters, and then all the way up to major renovations and capital improvements, such as envelope upgrades and lighting fixture replacements. So before developing a strategy to reduce energy and water consumption, it's important to understand what systems are responsible for energy and water consumption. The biggest drivers of energy and water usage will always vary on a building-by-building basis due to differences in primary building activity and occupancy schedules. So take, for example, a typical office building that uses around 12% of its total energy on interior lighting, compared with a stadium or a public assembly building that uses less than 7% of its total energy on interior lighting. Similarly, residence halls consume large quantities of water due to bathing and laundry equipment, while classroom facilities often use much less. Regardless of building type, however, core systems such as heating and lighting tend to be consistently high energy consumers across most building types. On the other hand, plug loads and process loads, including computer and food service equipment, are much more variable and can account for 30% or more of building energy usage. The primary consumption drivers for energy and water, and thus the recommendations generated during the assessments, will typically involve improving these systems. So for energy, we have HVAC, we have lighting, building envelope, water heating, appliances, and plug loads. And for water, typically what you're going to see is improvements to domestic use, restrooms, irrigation and landscaping, heating and cooling, kitchen and dishwashing, and laundry. The take-home point here is that understanding your building's use details, meaning primary building activity and occupancy schedules, that's really the first step to creating an accurate picture of energy and water consumption. So let's do a quick trivia question. Which of the following consumes the most water in educational buildings? Is it A, kitchen and dishwashing, B, domestic use restroom, C, heating and cooling, or D, laundry, or E, landscaping? Yes, so since this is an academic building, we're talking about there's very little laundry use or dishwashing taking place. The majority of water usage is going to involve hand washing and toilet flushing. So in this situation, we might recommend installing low-flow aerators or low-flow flush toilets that use probably around 1.5 gallons per minute for the aerators and about 1.28 gallons per flush for the toilets. We always recommend WaterSense labeled fixtures for these improvements as well. So here's another question. So which of the following uses the most water in restaurants? Is it dishwashing, domestic use restroom, heating and cooling, laundry, or landscaping? Yes, so since this is a restaurant we're talking about, there's a lot of dishwashing going on here. This is a prime example of how primary building activity directly affects water consumption. Restaurants really generate a tremendous amount of dirty dishes which require continual washing during business hours. So a recommendation here would be to install pre-rinse spray valves. Anyone who's ever worked in a restaurant before, as a dishwasher, probably used one of these before, the little things you use to rinse off dishes before you throw them in the washer. They use a staggering amount of water. I was blown away. Something about like a third of the water consumption in commercial kitchens goes towards pre-rinse spray valves. So replacing a standard one, which uses about 1.6 gallons per minute, with a WaterSense one using about 1.28, can save something like 7,000 gallons of water a year, which could translate to hundreds in savings. So while building usage is always a great indicator of what measures will likely produce savings, ultimately the best way to identify improvement opportunities is to actually carry out the building assessments. So buildings identified as leading candidates for capital improvements in the previous phase should receive always should receive an ASHRAE Level 1 building audit involving an analysis of utility bill histories and a brief walkthrough evaluation. The building walkthrough identifies low-cost measures for improving performance and generates a list of potential capital improvements and estimated costs and savings. This level of analysis helps to determine the potential energy and water savings for evaluated buildings and to identify and prioritize those buildings with the highest potential for savings on campus. After that, the buildings identified in the Level 1 audit as having the highest potentials for saving may require additional evaluation, which could involve an ASHRAE 2 level audit, which does a more detailed building survey to determine energy and water uses within the building, cost and savings for capital improvements, proposed changes to operations and maintenance, and basically just produces a more detailed summary. And then there's also an ASHRAE 3 level audit, which is much more detailed. We won't go into detail about that right now. So we acknowledge that assessments can be somewhat costly. So our guide offers information on various resources to help offset those fees. The first is to do some sort of student-led assessment program, where you actually use your students as a resource to actually go out and perform building assessments. There's also utility-provided complimentary or subsidized assessments. The Department of Energy actually offers a building energy asset score, which is basically a free standardized tool for physical and structural energy efficiency of a commercial building. It generates a simple list of energy efficiency ratings and provides recommendations for improvements. The New Buildings Institute offers a tool called their Retrofit Savings Estimator, which can be very helpful as well. And then you also have local energy efficiency programs that offer free or subsidized assessments. Examples include Grants to Green, which serves a nonprofit community, and also Interfaith Power and Light, working with faith-based organizations nationally. So I'd like to highlight a particularly successful curriculum-based assessment program that was developed at Penn State. The architectural engineering program recognized that students could be a very powerful resource for helping with the campus's energy efforts. So they decided to create a building retuning course to help educate grad students on the fundamentals of facility management. Essentially, the course allows students to perform actual assessments on commercial buildings and to gather data for improving energy efficiency through operational improvements and capital building upgrades. It created a unique opportunity where student coursework was actually fed back into the university's building operations and sustainability efforts. The course has been such a huge success that Penn State has actually made it available for other colleges to adopt and incorporate into their curriculum.
Phase 5 is implementation. This step is where it all comes together. This is where the ideas and the drawings on paper become reality. This is where all measures identified during the assessment phase as having the highest potential for energy and water savings should be scheduled for implementation and executed. This is the most important step and also the most difficult. Energy reduction strategies. We can generalize building improvements into 3 categories. Those are low-cost improvements that can be done today for immediate savings, behavioral changes which involve occupant education and may take a while to take hold, and capital improvements which require planning resources, construction time, and may often affect campus operations. Implementing low-cost measures. The considerable energy and water reduction uses can be achieved in a short period of time with little or no financial investment. These changes involve operational improvements including thermostat setbacks, reductions in hot water temperature setbacks, after-hour equipment shutoffs, and minor equipment efficiency upgrades including replacing incandescent or halogen bulbs with LED, insulating hot water pipes, and installing low-flow shower heads and faucet aerators. Now we're going to talk about implementing behavioral changes. Energy Star has demonstrated that it's possible to reduce energy and water consumption by at least 10% through occupant education, smart energy and water management, and collective behavioral change. Behavioral change is a top-down process that begins with facilities management and extends all the way down to occupants. You can reduce energy and water use through behavioral change by providing adaptive comfort controls, encouraging occupants to conserve through behavioral changes displayed on campus with visual aids, like the example shown here to take the stairs, and providing occupants with energy and water usage data with easy-to-use interfaces and a communication path to reach building managers. Taking advantage of the natural competitive nature is a great way to improve occupant behavior. Doing this will also foster collaborative and camaraderie across campus. The most common approach is to set up residence halls against each other and offer a prize for the building that is able to reduce consumption by the highest level. Every October, Emory University wages a campus-wide energy reduction competition, which pins buildings against each other for 3 different campus categories: residential, research, and administrative and classroom. Buildings from each category with the greatest reductions in energy consumption compared to the previous year are each awarded $1,000 to be used for sustainability-related purchases. Emory also uses social media to engage students and allow participants to share ideas about reducing energy consumption. These competitions are a really great way to provide recognition for hard work and to add to the campus-wide enthusiasm for energy management. So implementing capital building upgrades. When planning for capital improvements, there are several strategies that will help to reduce implementation costs, labor requirements, and construction project length. Often the upgrades recommended during building assessments respond to planned capital improvements. For example, a malfunctioning air conditioner scheduled for replacement can be replaced with a high-efficiency air conditioner, improving occupant comfort with the added benefit of energy efficiency. Planning for upgrades and replacing equipment before it fails allows time for adequate design and product selection. Emergency replacements often end in lowest efficiency equipment based on what is currently available and in stock. Another useful strategy is to bundle efficiency improvements. For example, combining the air conditioner replacement with a building automation system or submeters will do 3 things. It will support energy management, it will enable ongoing energy tracking, and verify the performance of the upgrades. Another example would be planning an LED lighting retrofit and controls upgrade with an HVAC upgrade, allowing for the reduction in the heat load produced by the lighting system to potentially impact the sizing of the new HVAC equipment. The bundling approach does require advanced planning, and it's important that you consider pre-planning the replacement of equipment within a budget and scheduled period versus on an as-needed basis. Implementation funding. Many institutions are reluctant to commit to efficiency projects because of the perceived cost of project implementation and having it not fit into their budget. It's important to remember that these improvements are an investment. The reductions in energy and water consumption brought by improved efficiency will translate into savings in utility costs, which over time will pay for the project and yield a high return on investment. Also, high efficiency technologies will generally require less maintenance, which adds to the long-term savings. Most utilities and government agencies offer a variety of rebates, tax credits, and other financial incentives to help pay for efficiency upgrades. Grant programs may be available in your location as well. Green revolving funds provide institutions with capital for energy efficiency improvements. The resulting cost savings are tracked and used to replenish the fund, allowing it to break even or grow. Once the project costs have been met through the energy savings, any remaining savings can be reinvested into the campus budget. Funding for green revolving funds can come from operating budgets, endowments, rebates, grants, government funding, and/or student fees. The Sustainable Endowment Institute offers resources to help your campus begin setting up a green revolving fund. Phase 6 is tracking and reporting. The key steps in this phase are measurement and verification, using building dashboards to promote awareness, and engaging students through coursework. So an important quote that you often hear talked about within the efficiency industry is so telling. It's measurement is the first step that leads to control and eventually to improvement. If you can't measure something, you can't understand it. If you can't understand it, you can't control it. And if you can't control it, you can't improve it. So why is M&V important? Once you've upgraded the efficiency of your campus buildings, everything is running smoothly, so just leave it alone and start collecting revenue from the savings, right? Wrong. The utility management process doesn't ever end. It continues throughout the life of the building through ongoing energy and water data tracking. The benefits of M&V are numerous. With this, you can verify the success of the energy reduction measures. The purpose of M&V is to make sure the measures are performing as estimated, to maintain efficiency over time. So measurement and verification goes hand in hand with recommissioning. M&V provides data that enables building engineers to verify that the building is working at peak performance. Ongoing data tracking will help identify system failures and unnecessary equipment runtimes. And then verifying your ROI, which confirms the financial success of the project to the institution. And communicating these results to donors and leadership can also support future funding requests for other efficiency projects. In the case of a green revolving fund, M&V allows for cost savings to be identified and reinvested. And demonstrating progress. Ongoing benchmarking allows for measurable demonstration of progress towards short-term and long-term savings goals. Value of submetering at Spelman College. Spelman is submetering at the building level, and currently has submeters installed in 6 campus buildings. Submetering has helped them identify leaks and technical issues with water and electric systems before they became an issue. For example, large spikes in interval submetering data led the facilities manager to inspect the cooling tower, and there they discovered that open valves were stuck open and were essentially going to end up costing a lot of money had they been allowed to fail for an extended period of time, and could have easily have gone unnoticed without the submetering interval data. With the submetering technology, they were able to identify and correct the problem before it accrued unnecessary costs. So that's a really important component to one of the things that submetering can offer. Helpful tools for M&V. Georgia Tech environmental engineering students at the Georgia Tech Research Institute that developed their own in-house dashboard with a graphic interface for monitoring building energy use. The cost-effective dashboard works in tandem with the building automation system to display the submetering data. And they're also benchmarking their utility use in Portfolio Manager. Building energy dashboards tracking energy and water, such as Lucid's Building OS, display interval building performance data. Dashboards are really important in communicating program progress. They allow facility managers and building occupants to make data-driven decisions about sustainable building use. Locating dashboards in public spaces or making them publicly accessible through a website make the information available to students, staff, and faculty. Dashboards also show progress supporting the energy and water reduction challenges between various buildings on campus, fostering competition and driving occupant awareness. So you can consider that dashboard as kind of like a scoreboard during those challenge competitions. By integrating those technologies into your campus energy and water management programs, the data gathered during the measurement and verification process can serve to educate students and staff about the role they play in energy and water consumption. Engaging students through coursework. Embedded within the energy and water management, improvement, and M&V processes are a number of valuable education opportunities. Data gathered through ongoing energy and water monitoring can be fed into course curriculum to educate students on energy and water use and data management, as well as more specialized topics, including energy modeling and assessing building performance. A number of schools have already into these opportunities. For example, Georgia Tech Research Institute mechanical and electrical engineering students are responsible for designing the energy and water dashboard, which we just talked about, which allows facility managers to track energy and water usage across the campus. And faculty idea sharing committees have proven valuable in supporting the integration of energy and water consumption data and related sustainability activities into the course curricula. So here's our call to action. We need your data. The industry needs more data, and your anonymous contributions support future research and help to advance the state of design, construction, and energy industries, especially within the college and university building sector. Participating in this progress gives your organization a unique opportunity to continue and contribute to commercial building performance data for the college and university building types. Reducing energy use and sharing success stories are key components to the Better Buildings Challenge. Better Buildings Challenge participants commit to sharing utility data, sharing information about the tools, technologies, and processes that help their campus reach their energy and water goals. The Building Performance Database is another resource. The Building Performance Database is dedicated to creating a comprehensive and centralized resource to help increase confidence in energy improvements and fuel future investment in energy efficiency.
All right, so the seventh and final step in the process is recognition. This is where you really actually get branded as a sustainable campus. Implementing a successful energy management program on your campus will improve public perception of your campus, boost your image, and help establish a name for your organization in the sustainability industry as a leading edge institution. Earning recognition will ensure that your hard work does not go unnoticed. A number of voluntary recognition programs exist that measure sustainability metrics for individual buildings on your entire campus and assign a ranking. Some of these programs will compare your results to a pool of other participants and assign a ranking. Scoring high in these programs will earn you meaningful recognition nationwide. Earning these accolades is considered a high honor, and many of them are very difficult to attain. Some recognition programs are specific to energy reduction, while others are much more comprehensive. So take, for example, STARS, which includes categories such as public engagement, course curriculum, waste reduction, research, food and beverage purchasing, the list goes on. So here's a list of campus-wide recognition programs. You have the Better Buildings Challenge, you have the STARS program, Sierra Magazine's Cool Schools, the Princeton Review Guide to Green Schools, and the Climate Leadership Commitment, just to name a few. And if your campus's energy program is limited to just a handful of buildings, it may be difficult to compete in a campus-wide sustainability program. You can still get recognition by achieving a green certification for individual buildings. So we've all heard of LEED certification. It's probably the most widely recognized certification program. LEED analyzes numerous aspects of buildings, including IAQ, materials and resources, energy and water efficiency, greenhouse gas emissions, operations, and sustainable site design. Emory University actually holds the distinction of having one of the largest inventories by square footage of LEED buildings in the nation. In 2001, Emory adopted LEED standards into all new construction projects. This is a picture of their LEED Gold plaque in their Rockville Residence Hall. Earthcraft is also another certification program we talked about a little bit earlier. Southeast's very own certification program. Similar to LEED, but more tailored for the Southeastern climate zone. Sorority Village at Emory received Earthcraft multifamily certification along with a number of other projects at Emory Point. For the really ambitious campuses out there, another option exists. It's called the Living Building Challenge. This is a much more rigorous program than LEED or Earthcraft, and only a handful of buildings on college campuses have ever achieved it. So in conjunction with the Campus Benchmarking Guide, we've also created a sister document that covers all things submetering. This document uses a series of case studies from a handful of college campuses around Atlanta, basically to paint a picture of submetering best practices. So those colleges are Spelman, Georgia Tech Research Institute, Emory University, and Agnes Scott. Each of these colleges have demonstrated highly successful submetering programs that have helped to do things like identify improvement opportunities and identify energy-intensive building system failures. The document also offers technical information about submetering your campus buildings, including a detailed analysis of the benefits of submetering. It also provides information about how to prioritize buildings to submeter, what utilities to meter, whether it be water, natural gas, steam, electricity, and it gives information about meter selection and meter maintenance. So that's all we got for today, folks. We encourage everyone to get a hold of the actual documents themselves because this was a very brief overview. There's much more information within the documents. So we thank you all for joining us today. Thanks so much. Bye-bye.